Let's see another technique today. It's called sliding window. So we'll see the problem and try to understand the sliding window technique. So the problem is sliding window maximum. So it's a hard problem, but so once you have better idea about the sliding window, then it will not it will not be so hard. So let's try to understand what is the problem and then how to solve. So if you see this nums array, then here the window is 3. So that means when we traverse each item through for loop, then we'll find in the window of this length 3, and in this window, the max is 3. So that's why one of our output is 3. And then we move this window. So we move window to this place, so we leave the first item, and that's again another window. So in this window, if you see what is the max item, that is also 3. So that's the second item is 3. Again we'll leave 3 and we'll make another window of size 3. So in this case, if you try to find out what is the max, that is 5. So it's a 5. So in this way, I will find the max item in each window, and that will be the output. So how to solve? So in this technique, in this problem, we are going to use basically 3 techniques we'll use here to solve this problem in a very efficient way. Yeah, so it's a very, and like if you try to solve in a very basic approach, not a very optimized way, then the brute force way can be, we can loop each item, and then there will be another loop. Inside that loop there is another loop that will run for 3 items, and we'll move the index. Again another run for 3 items, and then we find in the max in each the inner loop. So the first inner loop, go till here and then try to find the max. Again the second inner loop, second time the inner loop, iterate through these items, and then we'll find the max. So that is the very basic approach. We can also use the map technique, like in a outer loop there will be the outer loop, and then inner loop iterate to the max window, and then we can store the item in a map, and then we can see what is the max in this map. So that is in a very brute force way. If you try to solve in optimized way, then there will be 3 techniques I'm going to write here. The first thing is you'll use a for loop. We'll use a for loop, and then we'll iterate through each item, and then as soon as we get item, we form a doubly linked list, and in the doubly linked list just add that item, keep adding the item. So there's a comment, keep adding item in doubly linked list from backside. So keep adding item, doubly link is link is a doubly linked list. So that's the one thing we'll do, keep adding item in a doubly linked list from back. So doubly linked list is where you can add the item from the front, and also from the back. You can remove the item from the front, and you can remove item from the back. So this is the one technique. Here just we are going to use this. like keep adding item in a doubly linked list. And then second thing is what we will do when window size is 3 greater than equal to 3. So as soon as like we keep moving item one by one, like first will come just we add this item, this item, this item, but as soon as we see okay there are already 3 items in a window, then we'll get the max item, get max item from queue, get the max item from the queue. And here we are adding the item. Also what we can do, make sure the max item is in front of the queue. So we always put the item in the front of the queue. So we'll use this technique, and there will be another one more thing we can do, that there's a like when item is out of boundary, then remove item from the list. So let's try to understand this, what I said this, let's try to understand with this example. So here what I do, first I add the item 1 in a doubly linked list from the back side. So let's say I added the item 1, and then we also check and we go to the second item 3, and we'll check this 3. We'll check this this one is the one is less than 3. So if it is 1 is less than 3, so that is the next item. The 3 is going to come to our doubly linked list, but we'll see the one is already there, and if 1 is less than this 3, then we'll remove that, because we want to make sure the largest item is always in the front of the doubly linked list. So in this way, in the front there is a 3. Next time we'll get the -1 and -3, all are less. Then in this case 3 will be here, and if it is any item like less than 3, we'll remove from the doubly linked list. So in this way we'll maintain 3, and the next time when the 5 comes, the 5 will be in the front, and other lowest item will remove. So one technique will also make sure here, make sure the max item is always in the front in the queue. So that's this logic will do that. We'll make sure the highest item is in the front in the doubly linked list. So if the max item is in the front, then this logic comes again. When we reach to this window size, the 3 or greater than 3, we'll keep getting getting the max item from this queue. So in that way we can collect all the result, like 3, 3, 5, 6, 7. Okay, so let's write the code. So the for loop, I'm going to write the for loop here. So let's see, for I equal to 0 and I less than nums, length nums I plus plus. And here I can write window, another variable window is equal to k. So that k is the window. Okay, so we have the for loop, and then first we write this thing, keep adding items in a doubly linked list from the back. So let's create a doubly linked list. So in a golang, for the doubly linked list, we always use this list.new. So it will create the linked list, and it has all the functionality for the doubly linked list also. Okay, so this is the queue, and then keep adding item in a doubly linked list. So when I say like keep adding item in a doubly linked list, so here we have to we need to understand when we add the item, then we write like we add items index here. So we traverse through this list and we come to the first item 1, and then the index is 0, so we just add that index, and we utilize this index for getting the item out of this array. So the queue, and then so let's add the item queue.add. So the function is here like we add item from the back, so queue.push back, and then that's the I. So in this way we keep adding the item here, and in this block we are checking when we add the item in a queue, we make sure the max item is in the front. So how will you check? First we'll check if for queue length not equal to 0, or we can say greater than 0. So if the queue length is greater than 0, make sure the max item is in the front. So the first we'll get the first item from the back side from the queue. So item, or we can say index from back element, and this is the queue, and from the queue the back dot value. That's the interface, so I need to convert to the integer. So index from back is equal to index from back element, so this variable, and then convert to the int. So in this way I got the index, so index from the last from the doubly linked list. So as soon as we add 1, then index will be 0. So in this time we'll get the index 0, and we'll check here if nums and this index less than newly coming item, like say 3. So newly coming item is the 3. Second time when we go to the second item in a loop, so in the first time the index is 0, in the 0 index there was a 1, and we're checking okay if this index value 1 is less than 3, so 3 is the nums I. In this case we'll remove the item, so remove the item from the queue, and in this way when we remove the item in the queue, then the 3 will come in the front, so the max item will be in the front. So that's why I have written the comment here, make sure max item is in the front of the queue. Okay, so remove the item, so that's the queue, and remove queue from back, so you remove the item from the back, else break. So yeah, so in this way this loop makes sure the max item is in the front. Okay, so now we also need a result variable, so that we can when the window reaches to 3, we can get the max item from the doubly linked list and add to the result. So there's a result variable, result int, and we'll come here in this place, like when the window size greater than equal to 3 get max item from the queue. So then check if I, so we know like we keep iterating, so 0 1 2, so when it becomes 2, that means I greater than equal to window minus 1. So in this case we'll get front item from the queue. So the first time in our example the 3 was, let's say 3 was in the front, then we get this item 3. So first item index element queue front dot value, and first item index equal to this one int. So that's the index, front index we get, and now we get the item from the array. So result, go to append result, and then nums this first index here. Okay, so we are also getting the result. So one more case we need to handle this, like when the item is out of the boundary, then remove the item, because we see the 3, we get the 3, and in this way, like when we come to this place, and then the max item, again the max item will be the 5, but we are just getting the item from the front. But when we reach to the boundary, then we need to remove this 3 also. So next time the highest item, again 5, will go in front, and that will get chance to be added in the result. So for that, the condition is like, if first we'll check of course if queue length greater than 0, and then we'll check, we'll first get the first index, we'll get the first index element. So bring the first index element, we need to get from the front, so queue dot front dot value, and first index, so this one, and we'll check if first index equal to window whatever there is, it's like I minus window, because we are saying we keep moving the I, and then we'll reduce I minus window. So that means it will reach to the boundary, and in this case we'll remove the item from the first. So queue dot remove queue front. Okay, so I think that's the logic. We'll first yeah, so let's try to compile this first. Check the syntax here, line 50. Okay, we need to what is this? Okay, and this is for the loop. Okay, and then we need to return the result. So return the result. Let's try to run again. 50 missing return. Okay, we need to write this here after for loop. Accepted. Let's try to submit. Okay, so its a solution is correct. We'll see again the same technique in a Java also. So I have already written that code in a Java, so we'll go through the code. Yeah, so same thing here. We assign this k to the window, and we created a doubly linked list. So in a Java, this is the way to create a doubly linked list. And then we iterate through each item, and the first thing we'll do, keep adding the index to the last of the doubly linked list. So from the back side, we started adding this item, and then we'll make sure in this place, like make sure the max item is in the front. So that's why checking first is queue size greater than 0, and then pick last item, and we check the last item index, like nums, and whatever the index we have saved there, we are checking if that value is less than newly coming item. So what is the newly coming item? That is from the loop. If it is less than, then remove. So in this way, this logic makes sure the max item is in front, and here we are getting the result, and this is the this is out of boundary situation, and when the front item is the max, and when we reach the boundary, remove the first the max item from the front and give the chance for the another item. So that's all about this logic. So this seems a little bit difficult, but if you remember this technique, like how will you do, the first thing is keep adding the index, second thing is make sure the max item is in the front, and every time when we move the window, keep accumulating this, or keep getting the result, and also we check the boundary. So if you remember this main 3 techniques, then we can easily solve this problem. Yeah, that's all for today. Thank you.